how to solve those inequalities. So if I give you a simple, two-step inequality that, say, looks like this. 4x minus 7 is greater than or equal to 1. And I put that in front of you. You should remember how to do that, right? Okay, so I'm adding 7. 4x is greater than or equal to 8. Divide both sides by 4. X is greater than or equal to 2. Which meant on a number line, any number, as long as it was greater than or equal to 2, is a solution for this variable, right? Okay. The reason I'm reminding you of this is because of this. Negative 4x is less than or equal to 12. Do you remember the most important part about when you have an inequality sign in a problem and you are dividing or multiplying by a negative number, you must flip the sign, okay? This is me reminding you because if you forget to do that, it's going to come back and haunt you on today's lesson, which is what our last test before DC is on. So now that less than or equal to symbol can no longer go that direction because I just divided by a negative. To make this statement true, I have to flip that. That's the only thing I really needed to remind you about, right? Okay? So let's talk about how this looks for what we're doing today. So for today, I am going to ask you to graph linear inequalities. And you have a piece of paper in front of you that looks like this. It says graph linear inequalities, okay? Ignore all of that. This is from last year. So you have the sheet in front of you. Remember that y equals mx plus b. What does b represent? B is the y-intercept. Go ahead and write this in. It's where the line crosses over the y-axis. And m represents the slope. That's your rise over your run, right? Okay? So now, we have been graphing the heck out of linear equations, right? So we've graphed linear equations. Now it's time to graph linear inequalities, which makes you think, well, that's going to be pretty easy. So your problems today are going to look like this. The B still means the same thing. The M still means the same thing. The only thing is that now instead of an equal sign, I have an inequality sign, and that changes what your graph looks like. Okay. So, everybody ready back there? Okay, so I'm going to give you a piece of graph paper. You guys are just going to take one and pass it around. And on this side of it, I want to ask you, so you are paying attention. And if you're somewhere that you shouldn't be, then maybe you should move so that you can pay attention, right? Okay? So if I give you the equation y equals 3x plus 5, just put that somewhere. Y equals 3x plus 5. And I asked you to graph that. B is where you would begin. So you would go to your graph and you would count up 5. Hopefully 1, 2, 3, 4, 5, and you'd put a point. And from that y-intercept, where would I go? Good, I heard it, up 3 over 1. So you'd go up 3 over 1. And if you felt like, getting a few more up 3 over 1, you could go down and left. You could get a lot of good points. You really only need those 2, right? You probably don't have a ruler. Just kind of make a straight of a line as you can. Okay, so Gavin, I'm going to have you move up a seat, please. Behind Colby. Thank you. All right, so there's my line. The graph of that line is y equals 3x plus 5. Everybody agree? Yes. All right, here's what I want you to do. I want you to pick a point on that line. Any point. I'll pick this one. Okay? The name of this point is -1, +2. Right? -1, +2. If I asked you, is this point on the line? Well, you would be like, yeah, duh, because I'm looking right at it. But if I took this graph away, and if I said, I have a line called y equals 3x plus 5 is -1, +2 on the line. Another way they might say it is this a solution for that? How could you tell without this? Anybody remember? We plug it in. Plug in solves a lot. So I would put in 2 for y and -1 for x, and I would see if it equals it. So does 2 equal -3 plus 5? Does 2 equal 2? Yup. -1, +2 is a solution that falls on that line. That's how you tell. You plug it in and you figure out a yes or a no. Okay? Now, flip this over, and I'm going to change y equals 3x plus 5 into y is less than or equal to 3x plus 5. The good news is it starts the same way. You still start with your Y-intercept of 5. You still plot your rise and your run. 1, 2, 3, 1. You could still do a couple just like we did last time, okay? But the similarities end there, because now what I'm about to say is this. Normally you pick up your ruler. Actually, you know what I want to do? Scribble this out. Scribble the equals then sign out. So just make it less than. Normally, you would pick up your ruler and you would put it down and you would go whoosh, and draw a big old solid line and connect those points. But you can't in this case, because I want you to think about what I'm asking you. I took that equal then sign, or the equal sign, and replaced it with the less than sign. I don't want to know where the line is 3x plus 5. I want to know all the points that are less than that line. So now, when I had a is greater than 6, could it be 6? No. So when you plotted this, you had to put an open circle at 6, didn't you? So how can I represent this graph and all the points on it that are less than the line, but it can't be on the line? What could I do with a line that could maybe be the equivalent of an open circle? Instead of making a solid line, I could do what? Make it a dotted line or a dashed line. So when you pick up your ruler today, this is what you're going to do for some of them. So this is a dotted line. I still put my little arrows because it's still a line, but I'm still not done. So that was new part 1. The new thing part 1 was decide whether your line is actually solid or dotted. And then there's going to be some shading going on here. I'm going to color today. I have to decide. Now, when you drew a line, do you agree that you separated your graph into two parts? A part on this side and a part on that side. Okay? I need you to figure out, actually, and you know what? This is what we're going to do. I want you to pick a point on this side of the line and then pick a point on this side of the line. I made it 1, 2, 3, 4. I don't want to do 4, 4 because that's annoying. Let's do 4, 2. And then let's pick -1, -2, 1, 2, 3, 4, 5, 6. -2, 6. So right now what I'm asking you is, which one of these points do you think is going to be the part that I shade? Which one do you think, which area do you think is less than this line? I know this is the line. Is this less than the line, or is this that less than the line? Let's figure it out with some math. So let's take this inequality and let's plug in -2, +6. So let's take y is 6. I want to see if 6 is going to be less than 3 times -2 plus 5. Is 6 less than -6 plus 5? Is 6 less than -1? No, not the last time I checked. So guess what? The point -2, 6, when I plug it in, does not give me a true statement. So this point and everything to the left of this line is not part of my solution. So I'm guessing this one's going to work. Let's check it just in case. If my y is 2 less than 3 times 2 plus 5? Is 2 less than 6 plus 5? Is 2 less than 11? Yeah. Okay. So what's that? Did I mess something up? What did I do? Oh, 4. Okay, thank you. Thank you. I looked at Colby's face and I'm like, okay. This is supposed to be 4. So this is supposed to be 12 and this is supposed to be 17. Thank you. I was thinking. So now, either way, is it still true? Yes. Thank you for catching that. So now guess what I just discovered? How many of you, that was kind of the opposite of what you thought. How many of you thought that this is the side that I should shade? Probably, here's why. Common misconception. A lot of kids think to the left is less than. Please be aware of this. We are not talking about when we draw a line, there is no left and right. There is only above and below. And so I want you to look at this. If I am putting my pencil here and going this way, am I moving up or down? So this is my above. If I shade this way, this is my below. So what is that symbol? Less than. So what numbers are less than? Numbers above or below? Below. So then you take your pencil and you actually shade your graph. And the answers on your next test that you take are going to be, did you put the B in the right spot? Did you make the slope the right? Those are 2 things we've already done. The next new 2 things I'm looking for is, did you make your line dotted or solid? And did you shade above or below? So let's take this out and walk through this together, okay? So, if I am here, there are a couple rules to remember about graphing inequalities. So, the first thing I want you to do is to think about if you have a less or a greater than or a less than sign. There is no symbol below, is there? So if it's greater than, it can't be on the line. If it's less than the line, it can't be on the line. So what kind of a line should I use for those 2 symbols? A dotted line. Some people said dashed. Use it with dashes. That's okay. A dotted line or a dash line is what you're using for those 2. So then if I have a greater than or equal to and a less than or equal to, what kind of line should I use for those? Can the solution be right on the line? Yay, you know what? Let's discover that. Let's go back to this for a second. If I plugged in a point that was right on the line, and I figured that out, and I got 6 is less than or equal to 6, would that be true? Yeah. So if there's a line underneath it, the point can be on the line, which means I will use a solid line. Yep. Okay. So that's the first new thing. Dotted or solid. Okay. Now, I want you to know we're not shading left and right. We are either shading above or below. Those are the only 2 options you have, up or down. Which symbol means above? A greater than or a greater than or equal to? I don't care if the line is under there or not. If it is a greater than symbol, you need to shade the area above the line. If it's a less than symbol, you need to shade the area below the line. And then once we get these rules down, then we're going to actually try it and see what this looks like. So let's complete this table. This symbol for this was a less than. And because it's got to be less than, it can't be equal to. So I'm going to use a dotted line or a dash line. And because it's less than, I'm going to shade below. So let's try it for this next one. This is a greater than symbol. And a greater than means it can't be equal to it, so it's going to be a dash line. But greater than means shade above. So go ahead real quick and try to see if you can figure out those. Yeah. Let's see. less than or equal means go ahead and make it a solid line because the solution can be on the line. And as long as it's less than, you're going to shade below. Greater than or equal means go ahead, make it solid, and go ahead and shade above. All right, this means nothing until we actually start to see what it looks like. So flip it over. Y is greater than or equal to x plus 1. What's the y-intercept? Flying through this. You guys know this. 1. What's the slope? It's also 1. I hate this example. What does the slope tell us to do? Rise up 1, run right 1. So you could say go up 1 and then go right 1. Okay? So now what you just told me to do, let's do it. First, go down to this graph right here. This is actually a very step-by-step for somebody who's just learning how to graph for the first time. You guys know what to do. Plot a point at the y-intercept. There it is. From that point, this is a great review for graphing. Go up 1 and right 1. How many points do you need to make a line? 2. I got them. This is going to be the hardest part. You know, and I would suggest doing it in pencil. Here's why. Because what have kids been doing forever and ever and ever? They've just been taking it and drawing a big old solid line, and then they go, oh, shoot. That line was supposed to be a dash line. And then they have to do this. They have to go back and erase and make it look dashed. But in this case, I'm actually using a solid line, aren't I? So it's okay for this one to actually be solid. But just be careful because I guarantee you. All right, and now what I'm going to recommend you do is take your arrows and make them touch the outside edge of the graph because now you very distinctly have created 2 sections. Your final piece of this puzzle is figuring out which one of those 2 are you going to shade in. You got to go back up. So first of all, we're using a solid line. And this is a greater than symbol that was given. And greater than is above. So you're going to shade this area here. And that is